I thank you all for watching my videos all these years. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem which is related to the uniform continuity of given functions in the given interval. And this question is from the section Real Analysis, and it has appeared in the CSIR National Eligibility Test held in the month of June 2023. This question is from the part B, which is a multiple choice question, and it carries 3 marks. The question ID is 704026, and this question is suitable for all these examinations. Right. The given question is, which one of the following functions is uniformly continuous on the interval, open interval 0, 1. We are given 4 options. Option 1, f of x is equal to sine of 1 by x. Option 2, f of x is equal to e power minus 1 by x square. Option 3, f of x is equal to e power x into cos of 1 by x. Option 4, f of x is equal to cos x into cos of pi by x. Let us now discuss the solution of the problem in detail. We recall the following theorem. Let f be a continuous real valued function defined on an open bounded interval a comma b. Is an open interval a comma b, and it is bounded. It should be bounded. And what is f? F is a function defined on a comma b to real numbers, and f is a continuous function. Then f will be uniformly continuous on the open interval a comma b if and only if limit extends to a plus of f of x, that is the right limit of f of x at a and the left limit of f of x at b, that is limit extends to b minus of f of x, both exist finitely. Then f is uniformly continuous. It is a necessary and sufficient condition. Agreed. Now look at the functions given in options 1, 2, 3 and 4. They are all continuous functions. In the given interval 0, 1, the given interval 0, 1 is an open interval and it is a bounded interval. And the functions, they are all real valued functions defined on the closed and bounded closed interval, on the open interval 0, 1. Agreed? And they are all continuous. Right. So we first note that all the functions are continuous on the open interval 0, 1, which is bounded, and limit extends to 1 of f of x exists for every function f of x. Therefore, limit extends to 1 minus, that is the left limit of f of x at 1 exists finitely. So you need not verify this condition for all these functions. Therefore, we need to verify the limit extends to 0 plus of f of x for all these functions. It is enough to test the limit extends to 0 plus of f of x. That is the right limit of f of x at 0. Let us test the limits for all these functions one after the other. Option 1. F of x is equal to sine of 1 by x. It is well known. Sine of 1 by x, limit extends to 0 plus of sine of 1 by x does not exist. Anyway, I will show you. Limit extends to 0 plus of sine of 1 by x is limit h tends to 0 of sine of 1 by 0 plus h. Agreed. This is what we have been doing in our plus 2 courses. So that means limit h tends to 0 of sine of 1 by h, it's well known. Limit h tends to 0, sine of 1 by h does not exist. Therefore, f of x is equal to sine of 1 by x is not uniformly continuous on the open interval 0, 1. We take up the second function, f of x is equal to e power minus 1 by x square. Limit x tends to 0 plus of sine of minus 1 by x square. So write for x 0 plus h and take the limit as h tends to 0. That will be limit h tends to 0 e power minus 1 by 0 plus h square. Right. And that is equal to limit h tends to 0 of 1 by e power 1 by h square. As h tends to 0, 1 by h square tends to infinity, e power infinity is infinity, 1 by e power infinity is 0. So it exists finitely. So 0, it exists finitely. Therefore, f of x is equal to e power minus 1 by x square is uniformly continuous on the open interval 0, 1. Our answer to this question is option 2. Anyway, we will verify for options 3 and 4 also. Option 3, f of x is equal to e power x into cos of 1 by x. Limit extends to 0 plus of e power x into cos 1 by x. This is the product. The limit of the product is equal to product of their limits. Limit extends to 0 plus of e power x, which is 1, multiplied by limit extends to 0 plus of cos of 1 by x, which does not exist. Agreed. So therefore, this function is not uniformly continuous on the open interval 0, 1. Lastly, the option 4, f of x is equal to cos x into cos pi by x. Limit extends to 0 plus of the product cos x multiplied by cos pi x. Limit of the product is equal to product of their limits. Limit extends to 0 plus of cos x, which is 1, multiplied by limit extends to 0 plus of cos pi by x, which does not exist. Therefore, this function is not uniformly continuous. So thus, the answer to this question is option 2. That is the detailed discussion of the solution of this problem, and this problem is very, very easy problem. I am sure that you have understood the solution of this problem. Thank you for watching my video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Let's hope to meet once again in another episode of learning. I wish you all the best. Thank you.